Hi everyone. I'm Bhavesh, and I'm an AI researcher at CellStrat, and I'll be taking you through this workshop today on deploying AI models as a serverless API on CellStrat Hub. So so basically the agenda for today is going to be pretty straightforward. We are going to just understand what CellStrat Hub API is, a slight introduction to REST APIs, and we will be deploying the clip model, which is basically a model multi-model model, which has both vision and text, and it can basically align them. And basically, we'll be building a zero-shot image classifier with clip and deploying it. So that's just a demo model for us today. It could be any model at this point. And and we'll also be using Anvil to create a simple user interface for the deployed API. So let's get started here. Um, so CellStrat Hub API is basically a deployment service where you can deploy any model as a serverless API. That is, you only pay for the number of invocations, and you don't have to manage your own servers or anything, any of those things, and everything is auto scaled. So also it's free as of now. Like with 5 AP, you can deploy up to 5 APIs for free with like 1,000 API calls. And it's pretty straightforward to deploy a model, and like within 15 minutes, you can take your model from development to deployment. And in general, just so you know, every model is basically a Docker container. So if you want to get complete control over your runtime, you can get that access, but you don't really need to do anything. Mostly with Docker, particularly because everything is abstracted away for you. But if you do want to get under the hood, you can. So but before we even talk about deploying or any of those things, we need to like first uh, get on the same page of what an API is and what particularly a REST API is. So generally speaking, so I think this is for all the students, right, who are in the college hackathon. So a simple REST API is basically a interface between a server and a client. Like the client, let's say, makes a request to the API, and the API forwards that request to the server, and then the server processes that request and then gives that back as a response via the API to the client. So that is basically what an API is. It's a application program, and specifically this is a web API that we're talking about here, right? So in general, if we have any resource on our when you deploy your models and everything, your resources are basically identified by two things. So like second, it's better. So like so like there's a base endpoint URL, that resource, and then there is like a and after the slash there are like two things, two slots, one for your username and one for the name of your model. So similar to GitHub style or any of the general developer tools we have, right? So they always have like the location is always defined by the username slash the resource name, in this case the model name. So the same way we would be your model will also be deployed on our platform. So yeah, so in general, any HTTP request that you make to the API has a particular format. We'll just go over a few basics. So one is that there's always a method. So a method is we'll come to two specific methods in the next slide, but a method is basically like what kind of request is it. Then there's like the location, like where do you want to make that request. In our case, it will be making it to the CellStrat Hub. Then we have content type, like what kind of content is it. At CellStrat Hub, like any API call that you make to your model is basically a JSON request. A JSON is basically a dictionary. If you're in Python and all, and if you're in JavaScript, you have normal JavaScript objects, right? So, and of course, you also need to have your API key, which is your authentication. So all of this stuff is basically part of the header section of your request, and then comes the actual payload or the actual request uh, data that you want to send to the server, right? So that comes under the body. So that's the body of the request. Also, if you have any questions, feel free to ask them. If I am going fast, you can let me know. Yeah. So far, anyone has any questions? Okay. I assume no. Okay. So the next thing is we are going to talk about two specific types of requests in an API. One is a GET request and the other is a POST request. A GET request is basically a type of request where you don't send anything. So here we had a body, right? But in a GET request, you wouldn't really send anything to the server. You would just ping the server, sort of, uh, say hello or something like that. Like you just ping it, and the server will return you something. So it's like you are not sending anything, but the server will send you back something, depending on the location or where you are making the ping. So that's a simple GET request. A GET request is usually used to maybe, let's say, check the health status of a server or get some data back. But but you don't need to do any processing or anything. You just want to retrieve stuff. So in those cases, you would use a GET request. A POST request, on the other hand, is a give or take sort of thing. You give some data and you get back some data. So you post some information, let's say some input data to the server, and the server will respond with it will process that input in some form and then respond back with the output that you will get back. So that is a POST request. So I hope so. Yeah, these are like just basic API stuff, just to give you a background. If you have any questions on this, you can let me know. You can even type it in the chat or you can unmute it. Either way is fine. Okay. So yeah. So okay. Okay. So I'll just go over a bit on about the clip but model. So clip is basically a model trained by OpenAI. It came out, I guess, a couple of years ago. I guess 1 or 2 years ago, I think. But it's been used everywhere in general. So clip model is basically not particular, it's not being trained for a particular task particularly, but it's like a contrastive model, which basically can compare an image and a text and tell us how similar they are. So it's basically a similarity model if you think about it, but for text and images. So if you have a text, if you have one piece of text and one image, you can compare them and see how similar they are. So it's basically a interface between different input types, like text and images are both different input types and they're multi-modal. So the clip model is basically that it allows us to do similarity search in images or retrieve images, similar images, or um, you can even use it to like do zero shot classification and all of that. And that's what you're going to do today. So, so just a basic idea is that the way it is trained is like there are two encoders. One is an image encoder, the other is a text encoder. You in the text encoder there will be some text, in the image and there will be some images. So both of them will come to some embedding space, and the way your model is trained is such that the text associated with the image is always having a high similarity, that is one, or like the maximum similarity that you can have. So you're basically training the model to basically learn a embedding space such that your images embedding and the text embedding has very similar values, such that you can like, for example, Pepper the Aussie pup, like, and this is a dog. This is an image of a dog, right? So those two have the same content, but represented in a different format. So one is a text, one is an image. The idea here is that the clip model should be able to tell that they both are the same thing. So that's how it is trained. Right. So based on this similarity, what we can do is we can create an image classifier which doesn't require training. Like this is the pre-training stage, right? This is you're not training it specific for a single task, for a like a usable task, but you're just pre-training it and uh, um incorporating image and text knowledge together. But okay, so before I go ahead, like normally if you want to train an image classifier, let's say between a truck and a car. Okay, so I want to have a bunch of images of cars and a bunch of images of trucks, and I want to train a image classifier. What would I do? I would take a data set, preferably a labeled data set, and train a CNN model on it such that it classifies it, right? So okay, so that's works. Now let's say I add the a bike class to it. I want to recognize bikes as well now. Now, if I want to add a bike class, I would have to retrain the entire model, right? I would have to add a new data set and retrain the entire model with three classes now instead of two. So anytime I want to add a new class, it's going to be a very hectic thing. Like I will have to retrain the model and everything, right? So that's not ideal scenario, right? In the real world, you don't want to do that. Like if you even if you have one image, you should be able to adapt your model to those new classes. So that's where zero shot image classification comes in. So in zero shot, the idea is that you don't train or anything. You directly take a bunch of classes. Let's say I have plane, car, dog, and bird. And what we do is we take the text encoder of the clip model, encode all of those, and take the image encoder and encode an input image, any input image, the real world image, and then we train it on the hello. Sorry, I think my internet got disconnected. Yeah, is my screen visible? Yeah.
Yeah, this is
Can't hear you guys. I think I cannot hear you guys. I think from your end.
your screen is visible.
So, Bhavesh, it is all good. Are you there? Okay. Yeah, I think Bhavesh will rejoin. So, yeah, so while Bhavesh rejoins, so those who joined us later, thank you for joining. Uh, so, this is a workshop by CellStrat. We are a US-based startup, and we are launching at Dayanand College in Bangalore tomorrow and day after tomorrow, and we are doing this series of workshops. So this workshop is about AI deployment on the cloud as an API. Bhavesh, are you able to speak now?
Yeah, I think yeah, I can hear you
Yeah,
guys. Are you able
all
to see
good.
my screen?
Yes, yes, all good. Go for it.
Okay. Yeah. I don't know where I got disconnected. Did I complete the slide while I was disconnected or no?
Hello, Bhavesh. You were explaining
Yeah.
zero-shot classification and how it works basically. So you can start from
Okay.
zero-shot classification.
Okay. 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 Thank you. Yeah. So yeah, so I'll just explain that again. So now normally if you would do image classification, you would need to retrain your model and everything, right? So that's a hassle, right? So a zero shot classification, what you can instead do is you can take advantage of the fact that Clip can do similarity between images and text and create a zero shot classifier, which will basically let's say you have a bunch of classes, let's say plain car dog, you can frame it as a sentence like a photo of a dash. So a photo of a plane, a photo of a car, a photo of a dog, etc. Put them into a text encoder, embed all of those, and then take the image, your input image, and then see which one of these which one of these classes the image is most similar to, because this is basically doing similarity between images and text, right? So that way you can basically do zero shot image classification without having to train your own custom model for anything. So you can add more classes, reduce classes, any of those. So because it's not you're not training anything, you're just using the pre-trained clip model. It will work for any number of classes and any images for the most part. So yeah, any questions here? Anyone? Okay, I think. So yeah, so we'll basically be deploying this image zero shot image classifier using Clip. So so the way that we will do is we will decide we need to create an API, right? So we can decide on the format of the input and the output on ourselves, right? So in this case, we can and as mentioned that your inputs are always going to be in JSON, right? So in the APIs, right? Like you'll have usually like JSON format. So what we'll do is we'll send in a JSON object which has two keys. One is an image and one is a classes. The image is basically going to be a base64 encoded string of an image. So base64 encodings can be made for any files. It's basically a format to represent a binary to represent binary data in a string format. So with base64. Right. So if you have an image, you can turn it into binary format. You can extract the binary stuff, like you would read a file and then turn it into a base64 encoding. So that's what we're going to send in because that's a string. So we'll send that as an image. I send the file like that in that format. And then for the classes, we would have like plain dogs, or we'll have basically a list of classes, and we'll allow the model to basically recognize and give us an output like the plane is this much probability, dog is this much, cat is this much, or something like that. So this will be our output. So this is not something that is fixed. This is depending on your own model. You can decide on what kind of request format you want and what kind of response format. Your response is basically the output part. The location ID stuff is like external thing, but the output, the stuff in the output part is what you will be returning. Your model will be returning. So now you need to create a API, which will basically take this request image and the classes and return us a list of classes with their probabilities, right? And preferably in a sorted order, like with the first object being the one which is the actual classification. So yeah, so we'll actually do that. So let's actually get onto the hands-on part right now. So yeah, I think let me just presenting and go to the workspace. So you guys can log into your CellStrat Hub accounts. So if you don't like paste in the link direct to the console link point. Yeah. So yeah, once you log in, it should basically look something like this. And I'll give you a quick tour of the dashboard. So once you log in, okay, actually just log out and go to the console. So this is your sign in page. You log in with your credentials and sign in. And yeah, and then basically you will yeah. And basically this is your dashboard. So the way it looks is like you have your dashboard, you have start workspace button, the workspace status, your storage used and your current usage, your billing cycle and stuff, the machine specifications that you're using, and then there are expansion packs. So expansion packs are basically a bunch of a collection of projects based on different topics like deep learning projects, machine learning, NLP, etc. But right now what we are concerned mainly about is the start workspace thing. And apart from that, you also have some documentation resources here if you want to later on check out the process deployment process. But yeah, so the first thing is that just click on start workspace as soon as you log in to the dashboard, and it will turn to a pending stage. So this, it can take about up to 2 minutes to turn from pending to in to running state, basically. And also, once you start your workspace and use it, make sure you also stop it after you use it, because otherwise you will run out of your usage. So yeah, so I want you guys to all like this is because this is a hands-on workshop. You guys can all log into CellStrat Hub and follow along.
Those who need to create an account, just sign up, and in background, I will keep approving it.
So yeah, let's wait for it. So a few things, I guess, that I can meanwhile share is that all the models that we deploy here don't have access to a GPU, so it's a CPU based model only. And you get up to, by default, you get 4 GB of RAM for your model, but you can, on request, you can ask us to increase the RAM on your model up to 10 GB. And because these are serverless APIs, you will have a cold start. That is like if there has been no traffic for a while, it will go inactive. But once you make another request to it, it will come back online. But for the first time when it comes back online, it will take a bit time, like a minute or something. So there's a cold start to it, and you have like 15-minute timeout on the API. Like your request should be completed within 15 minutes. So that is one. So yeah. And there is a CellStrat API utility to make the calls. So currently it's available in Python. JavaScript will also come soon. So you can use that as well. Otherwise, you can ping me. I can share you the snippet. So you can call the API from a Python server or a client-side React frontend or any of those things. That shouldn't matter much. So yeah. Meanwhile, if anyone has any questions, they can let me know. Okay. So on my end, it turned to running status. So as you can see, the workspace is now running. So what I can do is I can click on launch Jupyter Lab, and what this will do is it will provision me a virtual machine on the cloud, and I can use that virtual machine on the cloud as my development environment. Okay. So this is your workspace. So a quick tour of the workspace. It's basically Jupyter Lab. So you have a file browser, file manager, or whatever you might want to call it, a file browser here, where you can have all your folders and files here. You have a launcher. So this launcher is actually can be opened with this big blue button here. So if you click on it, it will open up a launcher tab. And then you have like three kinds of notebooks that you can create: a PyTorch notebook, a TensorFlow, a basic Python one. And then you have like terminals, and you can create Python files and all. Yeah, that's mainly the important stuff, I guess. So what I'll do is I'll go inside a folder called workshops that I created. And just first delete the stuff. I have a folder called workshops. I'll create a new folder for this session. Okay. So yeah, so the first thing I want you to do is I'll share a drive link to a zip file so you guys can download that and upload it here. So let me just first share the link with you. So I sent it on the chat. So it's a drive link. You can download the drive link, the zip file in the drive link, and basically upload it. So to upload it, there's a button here called upload, right? So upload files. You can click on that and you will be able to upload the zip file here. Or you can just drag and drop also, that also works. So it's like I just dragged and dropped from my desktop. And once you put it here, you can just right click it and there should be a extract archive button option here once you right click it. Let me know if you want me to wait or anything. If you are following along and if you want me to wait, please let me know.
Should we have to download in workshop directory?
No, any directory. I just I had a lot of folders, so I just created a new folder. If your folder is empty, you can put it anywhere you want. That doesn't matter. So I'll just wait a couple minutes for you guys to catch up. So a quick repetition, I guess. I'll repeat just key. Like once you start your workspace, you need to click on Launch Jupyter Lab, which will take you to a interface like this. And I want you guys to like download the drive zip folder, which I shared in the chat, and upload it here with this upload button, or just drag and drop into the file browser and then right click it and click on extract archive. So that will give you two files in one folder. One is the images, which has some sample images for us to test our model, an inference.py script, and a clip.ipynvm notebook. So I'll just open that up. So just double click on the notebook and you should open it. And a few things. So there are different kernels available here. Kernels are basically like conda environments. We need the clip is using PyTorch. So we need to switch to a PyTorch one. So on the top right, if you see, there is a Python 3 written here, right? You can just click on it and you can change it to PyTorch and just click on select. Also, if whether you can see the status of your kernel here, like currently when it's idle, that means it's ready. And this is like a circle, right? So instead of a filled circle. Let me know if you want me to let me know like when you're on this, when you're ready like this, when you've changed the PyTorch kernel and you are ready to like run the code and all. So I'll give a quick overview before I run the code. is the first thing is we just install the clip library from OpenAI. So we just shift enter to run it. You can use this play button sort of thing. It will run that. And once that runs, you can now import the libraries like import torch. Yeah, go ahead. Sukhbir.
Yeah, I'm getting error in opening the zip file.
What does it say?
File load error for lib.zip.
Okay. So maybe just delete it. Maybe just delete and re-upload it again. So once you when you do upload it, there's a blue bar usually which says that if it's a large file, it would give you a blue bar saying that you can like it's uploading or anything. But one thing, just delete it and retry maybe.
Okay,
If
I
not, you can just locally unzip it and individually upload the files. That also works. Make sure the zip file itself isn't corrupted. Okay. Let me know whether ready. Did it work? Yeah. Yeah. I'll just explain the code meanwhile.
able to upload again.
Okay. So we just import our base libraries, and we also need to download the pre-trained model weights itself. So you can just run this wget to download that. When you run that code, it will like also you can use this refresh button to sometimes refresh the file list here. You can see there's a file which says vitb32.pd. So that file is basically your model file. And you can now basically load the clip model. We can just run this part to load the model. So a few things. We have a preprocess function, which will basically take an image and a class in the list of classes. And what this will do to the image is it will transform the image and turn it into a tensor. And it will take the classes and tokenize them and turn them into tensors as well. So the preprocess function will do that. And now we can just basically load some sample data. So we have an images folder here, right? So we have like, what I guess 7 images here. So we can just load all of those 7 images. And we can define a list of classes. So I just have this described. So these classes can be descriptive. They don't have to be single words or anything. It can be an action. It could be anything. So because this is a general model that was trained to align images with text, right? So you can say that Elon was wearing a face mask or just Elon Musk or like dancing, people dancing, kids dancing or any of those things. So your classes can be pretty much anything. It can be descriptive classes as well as just normal actual classes like plain car dog as well. It could be anything. So in general, the more descriptive it is, the better it is because this model was not trained on single words but rather sentences. So yeah, so you can have this. We have a list of classes, and then we have a predict function, which basically has the entire process. So we start by first pre-processing the image and the classes. So we take an image, a PIL image. We take the classes, we process them. Now we put them through the model. So our model will take the image and the classes and give us their normal logits, or basically the predictions, the raw predictions from the model. We will, which are basically cosine distances. We can turn them into probabilities by applying a softmax function over it. So we apply softmax on the logits per page. and get some probabilities, and then we just sort and format the output in the desired way. So our desired way was basically a list of lists with their class names and their probabilities, right? So yeah, so it will just sort them with the most highest probability being at the first, being the first, and the lowest being the last. So yeah, if we run this cell, we can be able to see the predictions. So as you can see, there's a prediction for the first image. It says a photo of dancing with 0.8808 probability, a photo of kids playing, a photo of aeroplane, a photo of traffic, etc. Accordingly, there's like sorted, and for each image we have our predictions here. So yeah, we had 7 images in there, so we have predictions for all those 7 images. So this is basically how the model works and runs. If you have any questions here, you can ask me, or I'll just take a pause here for a bit for you to just digest that. So yeah, so that's that. Now if you notice, apart from this notebook, there's also a file which says inference.py. So if you just double click on it, you can open it up. You will actually see that all the code that we just ran is just organized into a neat and clean like class format with a class and a bunch of functions and all of that. So what we are going to do is we are basically going to use this as our model source code. Uh, it's just organized in a class object-oriented way, but it's the same thing that we just ran here. So we can basically test that inference script by like importing the clip image classifier from here. So that's what we are testing in these 3 cells. We are just doing the same thing, just testing whether our object-oriented class of for the source code that works or not. Yeah, it seems like it's working. We are getting the outputs. So yeah, so that's basically the model. So that's we just now tested the model locally, ran the model. Now we need to deploy this model, right? So we will now start the deployment process. But before we do, I just want to know if everyone has been able to run the code so far, like till this local development part at least. Everyone or whoever is following along. If you want me to repeat anything particularly, you can let me know that as well. Okay. So I think I'm assuming I can go ahead. So now we'll start by to deploy the model. So to do that, the first thing we need to do is we need to create a Hub API project. So it's basically so we have a CLI, a command line interface called Hub, which will basically allow us to basically create a project and initialize a project basically. Which has some boilerplate code to basically deploy a project. It's like, for example, if you create like a Node project or if you create like a React project, or I think it has some boilerplate code already fixed with it, right? A templated format. So that's basically what this does. It initiates and creates a boilerplate project. So to do that, we need to first open up the terminal. So I'll just go ahead and click on this blue button, open up the terminal, and I'll just change directly to this directory that is workshop in Aventus because in the same folder. Yes. So yeah, so I'll start by doing hub init and naming my API something. So it has to be something unique in your own project only. So we'll name it clip classifier. Like within, if you already have a model which says clip classifier, it will basically override it. And I think I already do have, so I think I'll just override it. So hub init clip classifier will do that. So it's this command here, right? So you can just copy this command and paste it as well if you want. And it will basically say that project initialization is complete. So you can see there's now a folder which says clip classifier. If I open it up, it will have a few things. So let me just walk you through this stuff here. So there's a hub config.json. You don't need to do anything. There's a Docker file. You don't need to do anything here as well. There are two folders. One says model and one says src, which is basically source. So if you click on source code, there are three files, a main.py, which is the actual file which runs, a requirements.txt file, a utils.py. So main.py will basically contains a function with a decorator which says inference handler. So this inputs is basically where you will get your JSON input from the client request when you make an API call, right? So that is basically this inputs object, this inputs dictionary. It's basically a dictionary. So now, and with that inputs, you can basically write your code in this function here. You can maybe import some other function and use it here or whatever. But this is basically where this is the main function which basically gets executed when you receive an API request to your model. So you can do anything with your model here and then return the output in dictionary format again. So that's the main.py file. And then there is the utils.py file, which basically has one utility here, but you can add more utilities depending on your use case. So this is convert base64 to image. So this is a commonly used utility. So that's why we pre-ship it when you initialize your project, because in our image also, our image will be in base64, right? So we want to turn it into a pill format. So we can either NumPy or pill. So if you're using TensorFlow, you might use NumPy, but we are using PyTorch, and it usually uses pill format as the to begin with. So we'll set the return type to pill only. And yeah, and then there's the requirements.txt, which is empty text file, but here we'll add our libraries. But yeah, but we'll get to each one of them one by one. Apart from this, there's also a model folder, which is empty folder, but this is where you will place your model files. So the large models and everything. Now the reason is that the large model files are separately uploaded to the server, to our platform, and the source code itself is isolated. So to connect those two, there is an environment variable that you can use to get the location of the model folder once your deployment is complete, but we'll get to that in a second. Yeah, so that's basically, if you want to just open up the Docker file, you can open it. It basically contains a Hub API base image and some other stuff, but you don't need to change anything here, and you don't have to change anything here as well. So yeah, so the first step was to initialize the project, and we did that. The next step is integrating our own source code into the project. So the first thing is we have to copy this model file that we have, right? So this VIT P32 model. You have to copy that into the model folder. So I'll just cut it. So cut it, go to clip classifier, go to model and paste it. So it's also written here. So copy the VIT model file to the clip classifier model folder. So you can follow the instructions in the notebook as well. And the next thing is we update our source code. So I'll just copy. So you can just copy all of the source code and go to the source folder, go to the main.py file. So it's basically like copy this thing to the main.py file. So just Control A, remove, replace it, and save it with Control S. So now I'll just walk you through what is actually happening here. So yeah, also we have to paste our inference.py file as well, because that's where we are importing, right, from inference. So I'll just cut this again, go to clip classifier, go to source, and paste it here. So yeah. So now we have our main.py file here, which is basically importing our clip image classify class from inference.py. And yeah, okay. And Then we have from our utilities, we are importing the convert base64 to image. And then there is something called model dir here. So I just told you that our model file is actually inside this model folder, right? And when you deploy it, the location of the source code and the model folder is different because of the chain difference in their sizes. So to access your model files or that folder, that path to this model folder is basically available to you in the model del environment variable. So it's an environment variable that your model will have access to. So that will give you a directory, a path to a directory. And when what we can do is we can just os.path join with the model directory and the file name to access the files inside the model directory. So in our model directory, there's only one file and we need to just access that. So we just did this and we pass it into the clip image classifier. Did you guys get the concept of the model dir environment variable? Or do you want me to repeat it?
Can you tell me about bitv32.pt file?
That's the model weights. That's your model weights that we just used to. That's your pre-trained model. It contains the weights to your model. It's basically your model itself. What do you want to know exactly? Can you rephrase your question? Yeah. So B. Sorry.
How to get this file?
When you run this code, you will. Yeah, this cell, second cell, has the way to download the model.
Okay.
So you can just run these cells. And when you get to the deployment part, you can run hub init classifier and copy the model files to the respective folders that's specified here. Okay, so that's the model dir folder thing. So it's basically gives you a path to your model files. For anything that you have inside this folder basically is defined in this model dir environment variable. So now we created a classifier. So there's one thing. So when you load your models and everything, always load them outside the inference handler function because this part will only run once. And while your model stays active, it will only run the function. So you don't want on every request, you don't want to basically load your model, right? You want to keep it loaded like in advance and then only use the loaded model for making predictions. So, but once you go cold, it will run the above code again. But other than that, when your model is warm or it's basically active, it will only run this function. This part will already be run once. So, yeah. So inference handler. So now we take our inputs, and because if you remember, our input had a dictionary, right, or like a JSON object with keys and image and classes. So we'll convert our base64 image encoding of the image to a pill image, get that image, and then we'll also print our input classes just so we know, just for logging purposes. And then we'll use the predict function of our classifier to pass in the image and the input classes and get our output and return that output. So as simple as that. So we had our own source code in inference.py and we are just simply integrating it with the main.py file. We're just calling that function here. So any questions or anything so far? So yeah, so that's one thing. So we just integrated our thing. We also need to add our libraries. So you can just copy these libraries, 3 libraries that we need: torch vision, and flip library. So you can just open up requirements.txt and paste it here. So that's the only thing you need to do. So make sure your requirements.txt is filled. Just save it. And yeah. So that's it actually with the second step. Now we just need to build and deploy it. So, but before we deploy it, we need to first build the Docker image, like the package. So all of the source code and model, everything, all that has to be built, and Docker image has to be created. Even if you don't know what a Docker image, that's fine. But build step basically means is that it's going to basically install all the libraries that are required to run this code and create like a package, sort of thing, a runnable package for your model. So that's what we're going to do. So we were in our terminal, right? So we're going to change directly into the project folder, which is clip classifier. So make sure you're always inside the clip classifier project folder, like, or whatever project folder you are, and just run hub build. We'll do some pre-build checks. It will make sure your model, you copied your model files. It will make sure that you added your libraries in the requirements.txt, and then it will run some steps. So again, this process can take a minute to 2 minutes or something to complete. So yeah, meanwhile, if you have any questions or if you are lagging behind, you can ask me at any stage, like what to do at this step or anything, while we wait for the model to build.
So Bhavesh, this is building the Docker image, right?
Yeah, yeah. Yeah, so the Docker commands and everything is abstracted away, so you won't need to directly run them, but you just run hub build to do it. Yeah. So yeah, okay. So yes, the image, everything is built. Now, before we even deploy the model, there is one thing that we can do. So there's a thing called HubDev Mode, which will basically run the Docker image locally, and we can make an API request to it and see if all of our source code and everything is working. So because deployment will take time, and it's better to like first check it locally and then deploy it to the world, right? So we'll do that. So you can run HubDev now, and it will basically give you a local inference endpoint. So you can run it on, so it's a local host that will run inside the workspace itself. I can make post request to it. So you have to make post request with your payload to this API, and you can check whether everything is working or not. So we'll do that now. So if you come back to the notebook, there is local test, the API and dev mode section, where we just ran the HubDev command. So you can just run this cell. We'll load the images as base64. Yeah, so we're just loading all of the images and keeping a list of all the image strings and our classes. And then we'll just select a randomly some image and send a post request to the local endpoint with some headers and a JSON payload, and see if we get a response. So it seems like it's running. Yeah. So seems like everything's worked. We got an output which is kids playing, dancing, Elon Musk, etc., aeroplane, traffic, etc. So yeah. So even in our print statement, there should have. Yeah. So our model did work. Okay. So we have our everything is running here. So yeah, so now that our model is working, so before you deploy, make sure your model is running locally. So you can use the HubDev mode. You can make a post request to it with a JSON payload. So now that it's working, now what we can do is we can start the deployment. Now again, deployment is pretty straightforward. We just so to exit this local server running, in this Control C, and it will in the sandbox or the development environment. And now you can just run hub deploy. That's it. Now again, this can take about 2 minutes or something. So it will push the image to a cloud repository and deploy the model serverless container. So we can wait for it. So yeah, meanwhile, if you have any other questions, let me know.
So this is being deployed on AWS cloud, right? Serverless.
Yeah.
Okay. But that instance size and all will be appropriately selected?
No. So by default, your instance, your model will be on a CPU and it will have access to 4 GB of RAM. But if you want to but you can increase it to 10 GB. So depending on the model, like for most smaller models, so this is a serverless APIs, right? So this is not suited for large language models or any of those things, but this is mostly suitable for smaller scale models. So if you do need extra RAM or any of those things because on a CPU, you can ping us contact us and we can increase it for your particular model to up to 10 GB. The max limit right now that we have is 10 GB. This is actually basically being deployed on Lambda, right? So it's we have to follow their constraints.
Yeah, got it. Sure. Thank you.
We also deploy it on GPUs and all, but that's currently not available as a service for the end user as of now. But we do custom deployments though.
Sure.
Yeah, I had
And,
already deployed this model, so it says updating existing deployment. But yeah, go ahead.
and whatever the maximum memory size available in Lambda, right?
Yeah, that's 10 GB. Yeah.
Yeah.
Okay. So now our model is deployed. So you can see our inference endpoint is a long string with our username and our model name as the slash thing. Now we can make post requests to it as well, like we did. But post requests normally have a limit of like 4 MB or something. At least in this particular case, when you directly make a post. So, but rather there is something that we now recommend instead to all our users is the multi-step synchronous inference, which is we basically like call it MESI for short. So yeah, so but you don't need to really understand how it works or anything, but just to give you a brief overview, there's some content here. So like if your payloads are greater than 4 MB, so for example, images can be greater than 4 MB, and if it's like a video or an audio file, it could be much greater than it, right? So what we instead do is we make a get request to a particular input, like we make a get request to basically get a pre-signed URL, which will basically be an upload URL. We upload our file to it by making a put request to it. And then we also get an invocation ID along with that. And we basically make a get request to like username / model name / invocation ID to get back the results. So this is like a asynchronous sort of procedure. Think of it where you separately upload the payload, like and then you separately get the results back. But you don't really need to dive deep into it. So there's a utility, so you can actually copy paste this snippet code in every where you are using. So it basically takes three things: your payload, the API endpoint, which is basically just a username/model, and your API key. So we'll get to the how to get the API key in a second, and you can just, if you want, you can follow this. You can understand it's pretty straightforward. We can just use, so we'll basically use this utility function to make our API call. So, but for that, first we need to get our API key, right? So let's go back to our dashboard here. So if you go to the dashboard here, so this was our original dashboard, right? So on the top, there's a button called deploy models. Just click on that. And this is basically our Hub API dashboard. And you will be able to see, like if you don't have an API, you can basically create an API key. So let me just delete this key. So yeah, so you can just basically click on create API key, select your model, which is already deployed. So in this case, clip classifier. You can also select all the models if you want. This basically allows you to get access control for different API keys. So just create an API key. And now you have a API key specifically for this model that only works for this. So you can just click here to reveal, copy the API key, and basically paste it here. And also update the username here. So in my case, it's, so just update your API key and your username and just run this. So again, function and then this API and then this. So again, this is, as I told you, it's a serverless container, right? Deployed on Lambda. So you will have a cold start here. So this is a cold start. This is the first time you're making a API request or deploy it model. So it will take a minute or something to boot up and everything. Yeah, okay, it didn't take a minute, but yeah, it worked. Okay, so yeah, so we have our response here. So we can change it to some other image, let's say that is, but oh, I think it was an aeroplane image. So yeah, so we got aeroplane as the maximum probability. So yeah, so this is basically our deployed API. So so there you go. Basically, like we just deployed our image zero-shot image classifier, and now you can basically make use this utility function, or like if you are using a Python server, you can simply just use this utility function to make your API calls. Or we also have a JavaScript snippet for your front end, so that also can be used. That will be available on our documentation shortly. But yeah, apart from that, but if you do want to make raw API calls yourself, you can like go through the code. It's pretty straightforward. Like there are 3 API calls being made. But yeah, like we first send a GET request and get back an pre-signed URL. We upload our JSON payload to the pre-signed URL. Then we send a GET request to the API/invocation ID, and then we get back the response and return it. That's it, basically a 3-step process. Like you can make a direct simple post request as well, similar to how we did it for this, but it has a 4 MB payload size limit. And in general, I would not recommend using the post request. I would always ask you to, like, because be it small or big, this will always work in a better, robust way than the normal post request. So yeah. So yeah, so that is that. So that is actually the deployment. You can also see your deployed models under here. Click on it, you will be able to see the invocation history, the input payload and the output payload, everything is here. You can also see your model logs here if you wanted to. So you can see our model log had a print statement for the classes, right? So that's also here. So yeah. So you can like select from how many last hours you want to query the logs. That part you can do. Yeah, you can see all of that. And you'll also be able to see your API calls for the month. Depending on the tier, I think on free tier, I think it's about 1,000 API calls a month. But yeah, you can require, I think hackathon participants are given free upgrades to our higher tiers. That shouldn't be a problem. The other thing is that there is also an Anvil web app that you can create. So there's a link here which says clone the project. So I'll just give you an overview of anvil.works. So I'll just share the link here in the chat if you want. Anvil.works is basically a simple low code platform to build web apps using Python. So instead of JavaScript or anything, if you don't know web app development, you can use your own normal Python skills to build web apps. So there's a clone link that's shared in the notebook here. You can just click on it and it will open up a new tab where you can basically log in and clone the application. And it will say make clone clip image transfer, and they can click on make copy. So yeah, so once you do that, you will be able to see a UI. So there's actually, so here you can see the toolbox. You can drag and drop different components like buttons, labels, everything, and create a basic UI here. You can have a file uploader as well. And you can then have a source code. So this is design page. So there's a code tab as well, where, like, for example, I want to, when I click on make predictions, I want it to do something. So I'll do the split one. So predict click, it will basically, I'll get the classes separated by commas. So because we want a list of classes, right? So we'll just separate a comma, and we'll call a predict function from the Anvil server. So there's also a server module here. So this server module is where our CellStrat API utility function is here. So I just copy pasted that snippet here. And then we have like a Anvil server.callable. So I'm not going to go in depth about Anvil particularly because this session is not particularly about that, but there's good documentation in Anvil itself to learn about how to use it. So you can go through that. But basically we are just we have a predict function here, which will take our classes, our image string, which is basically a base64 image. We have our API key, the same thing that we just did in the notebook. We just make the API call and then return the response. As simple as that. And yeah, and then that's basically what we get our output when we call that server function. And we return and we set that output to a output label here. So there's this output text label. So we are just setting the text property of that label to output. So it's a straightforward thing. This will basically upload our base64 and encode it bytes, that sort of thing. To just run this, you can basically, once you clone it, you can just basically click on run and it will basically run it. You can also publish it. That's also free. So we can do that. So I'll just upload a random image. It is an image of dancing, and then I'll add some traffic, some normal class cars playing or something. And I can just click on make predictions. And it should give us an output. Let's see. Oh, I think I need to change the API key, sorry. So when you clone the project, make sure in your server module you change the API key. So let me just update my API key here. And also your username here as well. So make sure you do those things. So the username and the API key. Okay. So now I'll just run this again. Yeah, so as you can see, dancing, traffic, cars, the normal JSON output. So I haven't beautified it anything particularly in the UI, but that's up to you. So this is just to show you how a UI could be made using Anvil or anything. Like a basic UI could be used with Anvil. But yeah, you can also, your UI could be on anything. You can even use Gradio or you can use Streamlit or in Python. But if you are if you do have a web developer on your team, they can create a proper React frontend, normal HTML, CSS frontend, or whatever you want. You can just make API calls to it from the front end to call our thing, or you can have a separate server, Python server on Heroku, which calls this API as a proxy. So that's all up to you. So yeah, so this is basically it. this was the thing. If you have any questions, you can ask me. Otherwise, there's one last slide I want to talk about.
I want to ask a question.
Yeah.
Can we also upload the pickle file?
Yeah, any
Dot
file
pickle.
works. Yeah, dot pickle file in the model file as long as it works.
Yes,
Yeah,
yes.
you can use it. And it's up to your model source code. So you don't have any restrictions on your source code or anything. You just have to follow the process that you make sure you use the model dir os.path sort of format to access those model files when you're loading it in your source code. Because your model, like for example, your model, you cannot just write that this is your model or anything. You have to append it to the path of the model dir because your model files will be accessible somewhere else. So that model dir is basically the location of your this folder in the cloud. So just make sure paths and everything are correct when you do use your custom files.
Okay.
Anything else, anyone? So yeah, once you do this, you can go back to your dashboard by clicking on the logo here and make sure you stop your workspace though. So your model will still be deployed, that won't stop, but like your development error, otherwise your usage will run out. So just stop your instance once you're done with the development part. And apart from that, there is one few important points that you should know. I'll just cover that quickly. So one is that your deployed models don't have access to the internet. So keep all your downloaded stuff beforehand in the model folder. So that is one thing. As I already mentioned, you don't have access to GPUs as of now. And by default, your models will have access to like 4 GB of RAM. And on request, it can be increased to 10 GB on request. So APIs also have a cold start. So that also I think I mentioned. For the first time, they will take a bit time, or like for when there has been no traffic for a while, it will go cold, or it will like go inactive or something like that. So it will take a bit time to come back again. So usually a minute is enough. So for most models, a minute is the cold start time, usually maximum like a minute. For our model, it didn't take a minute. Took about 20 seconds, I think. But yeah. And also there's a timeout limit of 15 minutes for the API. And in your model code, if you are like writing any temporary files, you need to write them to the /temp folder because that's the only system that is writable folder. The other parts are read only once you deploy a model. So in your code at runtime, if you want to make any write request, write any temporary files or any of those things, you need to write it to the temp folder. And you can use the CellStrat API utility that I shared in the notebook as well to make your API calls, which abstracts away the 3-step process of API calls, which separately uploads the input payload to override the 4 MB payload limit. And also you can use the hub logs command. So I showed you the logs in the console, right, in the CellStrat Hub dashboard. That apart from that, you can also write hub logs in your terminal to view the logs for your model. That also works, but you do need to remember that the logs can take like up to a minute sometimes to update for the latest invocation. Let's say you're facing any issues or anything. So yeah, thank you. I guess if you have any other questions, and let me know. Otherwise, that's basically the end of the workshop. I hope you were able to follow along and deploy a model. Also, this is available as a recording, so you can watch this recording again and follow along again to deploy it and at your own time. So, and also the docs are also available in the dashboard. You might have seen there are some documentations that you can access. Let me just share that as well. Yeah. So like if you click on documentation or any of those buttons, it will open up the documentation. So you're like on the hub deployment side, you can get the hub quick start, testing and debugging and all of those stuff. And there are some recordings from the past workshop as well. So this clip is basically the one that we currently did. Some other sample models for you to understand if you want. But yeah, that's basically it. Any final questions or anything? Anyone?
Is it fine showing workspace status stopped
Yeah,
in my
if you
dashboard?
did you okay, I think that means it stopped automatically, or did you stop it?
I didn't stop that
Okay, then it
automatically.
might have been like because you were inactive for a while, it might have stopped automatically. Yeah, but you can start it again, or you can just refresh the page to verify if it's actually stopped or not. Yeah, I think if no one has any questions, I think we can end the session and stop recording. So thank you everyone for joining. I hope you were able to understand the deployment process. Have a good day.